Hello friends. In this video, let's have a look at problem 515. Find largest value in each tree row. This problem can be solved by a wide variety of methods. So in this video, we plan to present two formats. So one is a level order traversal, which I feel suits the problem very well. Another one, basically I want to use either breadth first search or depth first search, or breadth first based traversal or depth based traversal. First, let's look at the problem statement. So here we are given the root of a binary tree. We want to return an array of the largest value in each row of the tree. So for example, in this example, the first row just have the root itself. So the largest value is 1. While in the second row, so we have 3 and 2. So the larger one is 3. And in the last row or last level, so we have 5, 3, none. So the largest is none. So we have 1, 3, none. So the output is the value, right? So in the second example, so we have one root is 1. So the left subtree is 2, right subtree is 3. So the first level will be 1. And the second level, the larger one, will be 3, right? So with that said, you can quickly have a look at the constraint, so we can move forward to the coding part. So in the first version, I'm going to introduce level order traversal, right? So this actually is very suitable for this problem. On one hand, we have 10 to the power 4 nodes at most, so this is not very large, so we can do this. So first, let's check a special case. If not root, so we're going to return the empty one, right? Otherwise, let's initialize a result variable, and then we are going to initialize a level. So let's call this the root, right? So this contains the root itself at the very beginning. So now let's do a while loop, while level. So in other words, it's a non-empty array or list. Then what we want to do, we first get the maximal, right? So maximal will be the max. So the node values in the current level. So that will be node value for node in level. So with that said, we retrieved the information for the current level. And then we need to add this to the result. And next, we are going to update the level. So this can be updated using a list comprehension. So we want to find the children nodes. So for child, for node in level, and for child in either the left subtree or right subtree of the current node. So we are going to use node left and node right. So we only care about the child that is not null, right? So this way we update the level. So after the while loop, we actually can retrieve the required information at each level. So we just need to return the result. So now let's have a look at the test. Yeah, it passes one test. Now let's look at the generic case. Yeah, it passes all the cases. So for more information, actually you can print out the maximal, right? So let's do something like this. So we can print out. So first, the current level, right? So for the current level, we just print out the values. Let's see. We can add one more. So values. So node. So I'm going to copy this part. Let's write with some redundancy, right? So values, that's going to be this one, right? So the values, the level contains this one. So the values, and the maximal will be the maximal, and the result state will be result. So now let maybe do this. Let's test. So the first level is 1, so the result will correspond to this one. And the second level, we have 3 and 2, right? So if you look at this example, then we're going to append 3. And the last level we have 5, 3, none. So we're going to append none. So we have 1, 3, none. So this is the one solution format. So now I'm going to comment out these two lines. And then this is one way of doing this. So this is very standard pattern for level order traversal. So actually for trees, we have a lot of different ways of traversals. For example, in order, pre-order, and post-order. So now let me implement one based on pre-order traversal. So I'm going to call this one V1. So now I want to build using a depth first based solution. Depth first based. So also let's say call it DFS or something. Traversal here is. So for this, again, I'm going to check if it's a null tree. We're going to return empty, right? And next, we're going to initialize a result variable. And then we are going to, let's see, we are going to record the level, right? So let's do a stack. So root, let's say root at level 0, right? And then we do the standard traversal. So first, let's get the node and the level. So as pop, right? So pop from the right. So we regard the right as the top of the stack. Then if level equals the length of this result, it means that I'm looking at the first element or first node in the level or in the row, right? So then in this case, we just need to append, right? Result append this node value, right? Otherwise, for example, at a level, if we look at other nodes, so we know that we already at this position. So this result, the index you can regard as a level number, right? And then we already have the information if we look at the other nodes in the same level. So what we want to do is we do some update. So result level equals max the previous state, and then the current node value. So this is this check basically updates the result information. So now if we do not include this if else block and we add left child and the right child into the stack, it's a standard depth first search. Or so in this case, I'm going to add the node right first. If node right, so what I'm going to do is s append node right level +1, and then I'm going to check node left. So I'm going to append node left level +1. So then after this, I'm going to return the result. So here I'll postpone a little bit to explain why I put this right first and then do the left. So now let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. Now I want to make two comments on the second solution format. First, the order here, if you check right first or check left first, does not matter for this problem. So for example, if we cut this part and put it here, the solution still works. But I want to recover back. So the reason I first check the right and then do left, so this order yields pre-order traversal. For binary tree. So you can actually analyze the code to digest this part. So now let me maybe do this. So we can print out this information and then do this. So what we want to do, print f. So node, let's use node value to do that. And see level we'll use level, and the result, let's use result. So now let's run this code. So you see here in the standout, we first visit the root node 1, and then we visit the left subtree 3. 3 is the root of the left subtree, and then we visit 5, and then we visit this 3. And after we finish traversing the left subtree, we look at the right subtree. Then we first visit the root of the right subtree, that is 2, right here. And then we look at the left subtree now. So then we look at none. So this is the pre-ordered traversal, right? So with that said, I guess we covered a bunch of information for this problem. Actually, this problem is marked as medium by LeetCode. And if you have practiced quite a lot on tree traversals, and then basically this problem is a practice problem. But the advantage is that a priori you can solve this problem, and then you can tweak the code and to digest some details. So with that said, I guess that's about it for this video. So you are welcome to follow up our channel or playlist inside in the channel to look at more problems or practice more. Thank you.